Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over part 2 of the Nevada High School Proficiency exam for mathematics. We'll be doing problems 6 to 10. To gain access to this document, you can simply go to this site right here. Do not forget to visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, let's take a look at question number 6. We're given an equation and we are asked to find which is an equivalent equation solved for y. Okay, so we have 4x to the second power minus 1 divided by 2y minus 9y minus 5 divided by 3 equals z minus 3y. Now I'd like to express all three terms as fractions. Since this expression has no denominator, I'll divide it by 1. That's the default denominator. Now, I'd like to get rid of the denominators, 2y, 3, and 1. In order to accomplish that, what I'll do is I'll multiply each term or each expression by the LCD. All right? So what is the LCD of 2y, 3, and 1? The LCD, lowest common divisor, of 2y, 3, and 1 is simply 6y. All these three terms go into 6y evenly. Okay? So what I'll do is multiply everything by that. So I'll multiply this term by 6y, multiply this term by 6y, and then multiply this term here by 6y. So why am I multiplying everything by 6y? Since the denominators go evenly into 6y, we can divide them out. All right? So let's divide 2y here once. 2y goes into 6y 3 times. 3 goes here once. 3 goes into 6y 2y times. And then 1 just goes into 6y once. We can just drop this one. Okay? All right. Now let's simplify. We have 3 times 4x squared minus 1 minus 2y times 9y minus 5 equals z minus 3y times 6y. Now let's take a look at what we have just accomplished. We have eliminated the denominators. All right? Now let's not forget our goal. Our goal is to solve for y. We want to get y isolated. So let's simplify these expressions by getting rid of the parentheses. To do that, we'll have to distribute. Okay, distribute the 3. Here we'll distribute negative 2y. Here we'll distribute 6y. Okay, so what does that yield? We have 12x squared minus 3 minus 18y squared. Now you have to be careful here because you're multiplying a minus and a minus. That yields a positive, okay, plus 10y equals 6yz minus 18y squared. Okay, now what we're going to do is collect all the terms with y on the left side and everything else goes to the right side. All right, so let's see. I need 6yz to the left since it's it has a y in it, so I'll subtract 6yz from both sides, 6yz, and then subtract 6yz. Since it's it's not similar to any of these two, I'll put it over here. Now, let's move 18, negative 18y squared to the left side. We're going to add 18y squared to both sides. 18y squared is similar to this term right here, so I can put it under. And then 12x squared needs to go to the other side, so I'll subtract 12x squared. Well, let's simplify this first since I'm running out of space. All right, let's simplify this. So what we just did is we just moved all the terms with y's to the left side, okay? So let's simplify that. We'll have negative 6yz plus 12x squared minus 3. Now these two are like terms, so they're opposite, so they cancel out, plus 10y. And then what do we have left on the right side? We don't have anything, equals 0. Okay? Now, the terms without the y, let's move it to the right. How do we accomplish that? Subtract 12x squared from both sides. And then add 3 to both sides. Why do we pick these two terms? Well, we picked these two terms because they do not have y's in them. Okay? Now we'll simplify that. We will have, let's see, what do we have? We'll have negative 6yz. These two add up to 0. These two add up to 0. Plus 10y equals negative 12x squared plus 3. So the goal again is to get y isolated. Now if you look at the left side, since y's are present in these two terms, we can proceed to factor out the y. Okay? So we factor out y, we'll have negative 6z plus 10. Notice when you factor out the y's, as though you divided y's out of this. So this y is divided out, this y is divided out, and it's factored out to the front. That is equal to negative 12x squared plus 3. Now to get y by itself, we're going to divide both sides by this quantity that y is being multiplied by. Okay? So divide these two sides by negative 6z plus 10. And then here negative 6z plus 10. Okay, if we do that, we're going to end up with y equals negative 12x squared plus 3 divided by negative 6z plus 10. Okay, now, which expression does this result we just got match? Let's look at it. We have this expression right here. Which one does it match? It doesn't match any of these answers. So what's lacking? What haven't we done yet? You notice that all the options, these two options here, are factored. So is it possible for us to perhaps factor this expression? The answer is yes. So let's go ahead and do that. In the numerator, I can factor out the greatest common factor, negative 3. And then down here, I can pull out the greatest common factor, which is negative 2. All right? So if we pull out the greatest common factor, we'll end up with y equals negative 3 times the quantity. If you take out negative 3 from negative 12x squared, you will be left with 4x squared. If you take out negative 3 from positive 3, you end up with negative 1, minus 1. Okay? In the denominator, remember what the greatest common factor was. It's negative 2. So if we pull out negative 2, we'll have negative 2 times negative 2 divide negative 6z divided by negative 2. You'll be left with 3z. Positive 10 divided by negative 2. You'll be left with negative 5. Okay? Alright, and then minus divided by a minus is plus, so we can slash and dash this. And then that's our final answer. Y is equal to 3 times 4x squared minus 1 divided by 2 times 3z minus 5. Okay? So let's see which one this one matches. Let's write it here again so we can compare them without scrolling up and down. Alright, so there goes our final answer. Okay, so we can clearly see that answer to number 6 is option A. Of course, z cannot be 5 over 3 because if z is 5 over 3, we'll have an undefined output value. So this value of z must be excluded from the domain of your solution. Alright, so we don't need this piece to get the answer. We already have a match with the expression, so this is our result. Okay, let's take a look at question 7. It says to determine what type of music people in a city listen to most often, employees at a radio station polled each person who entered a grocery store between 2 p.m. and 5 p.m. on Sunday. Which term best describes the people who were polled at the grocery store? Okay, so if you take a look at this problem, they wanted to get an idea of the type of music people in the city, the entire city, listen to. Okay, so let's say this circle represents the entire city. Now, what did they proceed to do? They polled people who entered a grocery store in the city. Okay, so we have a grocery store in the city. It represents a fraction of the population of the city. Okay, another word for a piece of the entire population is a sample. Okay, if you just take a small fraction of an entire population to gain an idea as to what the preference of the entire population is, what you're extracting is just a sample. Okay, so that's what is being used to describe the kind of selection that's been done here. So the answer is sample. Okay, now let's take a look at question number 8. We're told that Marvin records gas mileage of 48 different cars. The histogram below displays the data Marvin records. Based on the histogram, in which range is the median gas mileage of the cars? Okay? So one thing you want to note is that we have a total of 48 cars. Okay? Total of 48 cars. Now we are asked to find the median. Another word for median is the middle. Okay? Now if we are accumulating the number of cars from the minimum and from the maximum, the upper and lower bounds, where is the middle going to be? Okay? What's the middle value that we are trying to find? Well, we have 48 cars, so we simply divide it by 2, so we can split the entire range in half. Okay? So 24. Now, if we are accumulating the number of cars from 10 all the way, starting from the left and then accumulating from 45 downwards, where is 24? 24 cars going to fall? Okay, any range that this 24 falls in, when we're accumulating the number of cars, that is the range that is the correct answer. All right, so let's go ahead and demonstrate how you can carry out your accumulations. In order for us to accumulate from any direction, we need to know the number of cars in each interval. All right, so we can just call this, let's call this 3 right here. Say this is 3 is less than 5, so let's just call that 3. So let's call that 3, and let's call that 4. Okay, and I'm going to call this, let's call it 13, and then I'll call that 12. All right, so we have, so don't forget, this is 5. This is 5 right here. Up here, this is 5. I'm calling this 4. I'm calling this 3. And then this is, let's call it 13. Somewhere below 15. And then let's call this 12. All right. I'm basically looking at this calibration and making an educated guess as to what the number could be. All right. Okay, now let's go ahead and do our accumulation. So let's see. Well, 3, let's see. I think let's call that 2. Looks a little bit too big. If we call it 2 or 3, we'll still get the same answer anyway. So let's just call that 2. All right, so this is 2, and let's call that 2. Now, in this range from 10 to 15, how many cars do you have? You have 2 cars in this range. Now, accumulating from the bottom, when the sum exceeds 24, then we know that we need to back up. Within that range that we exceeded, that's where the median lies. So this is 2. We know that the median doesn't lie here because we have accumulated only 2 cars. In this interval 15 to 20, we have a total of 13 cars. If we're accumulating from 10 all the way to 20, we have a total of 15. That's our accumulation. Have we exceeded the median number, which is 24? The answer is no, because now we just covered 15. In this interval 20 to 25, we have 12 cars. What's the accumulation here? The accumulation from 2 to 25 is 2 plus 13 plus 12. 2 plus 13 plus 12 is 25 plus 2, which is 27. That's over the limit. Okay, so let me illustrate that for you. If we accumulate from 10 to 20, the total number of cars there is 2 plus 13, which is 15. That's too small. When we accumulate from 10 all the way to 25, we have 2 plus 13 plus 12. That's 25. No, 27. Okay? 2 plus 13 plus 12 is 27. That's too big. So what does that tell us? It tells us that the range 24 resides somewhere in between here, because 24 is between 15 and 27. Okay, so that's just by accumulating from the left. Okay, so from accumulating from the left, we can clearly see that our answer is option letter B, because that's the range that this median value falls in. Now you can also accumulate from the left. Okay, in this example I just did, I accumulated from the left, so we can also start from the right, I meant to say. So what if we're accumulating from the right? When will your accumulation hit 24. Okay? As soon as we exceed 24, when accumulating from the right, then that interval that we just passed will be the interval that has the median value of 24. Okay? So let's go ahead and do that. You don't have to do this. I'm just showing you another way you can approach the problem. You can go either from the left or from the right. You should get the same answer. If you get a different result, then that means your mathematics is wrong. Okay? Okay, now let's start accumulating from the right. In this interval, we have two cars, two small. In this interval, we have four cars. Accumulating from the right, from 45 to 35, we have six cars, two small. Accumulate more, five. 2 plus 4 plus 5 is 11. Too small. Remember, our target is 24. Okay, here we have 10 cars. So this is 2 plus 4, 6 plus 5 is 11. Plus 10, that's 21. That's too small. Okay, if we accumulate from 45 all the way to 20, we have 21 plus 12. 21 plus 12 is 33. That's way too big. So that tells us that we have to back up. This is where your interval is. Okay, so let me illustrate it for you. When we're accumulating from 45, let's draw it this way, from 45 all the way to 25, what was our net accumulation? How many cars did we count? 2 plus 4 plus 5 plus 10. 2 plus 4 is 6 plus 5, 11 plus 10 is 21. That's too small. So it cannot be in this interval. Okay? So what did we do? We proceeded to accumulate further. We went from 45 all the way to the next interval, which is 20. We went all the way here. Okay? When we accumulated all the way here, what did we get? We got 21 plus 12, which is 33, and that's too big. So what does that tell us? It tells us that this is the interval where 24 lies, because 24 is between 21 and 33. Just as we determined here that 24 is between 15 and 27 by accumulating from the left. So we can see that by left and right accumulation, we can simply conclude that our median is between 20 and 25, which is a value of 24. So 24 accumulating is somewhere here. Answer is option letter B. Let's take a look at question number 9. It says, in which graph do line M and line P represent a system of equation that has no solutions? So if a system has no solution, that simply means you have no intersection. Okay? So don't forget, no solution implies no intersection, because your intersection is your solution. Okay, so no solution implies no intersection. Okay, so we are basically looking for two lines that never intersect. Okay, two lines that never intersect. So two lines that never intersect basically have two properties. Number one, they have the same slope. And two, they have different intercepts. Different, we can say y-intercepts, different y-intercepts. Okay, now let's take a look at these graphs. Which ones have the same slope and different intercepts? Well, since we know that any graph that meets these two requirements never intersect, we can save time by eliminating graphs that intersect, okay? Graph A, it looks like they never intersect, all right? But we can also notice that their intercepts are different. This intercept of M here is, the B of M is -1. And then for line P, the B is 1, 2, 3, 4, -4. Oh, they have different y-intercepts. But what do you notice about their slopes? They have the same slope. This has a slope of rise 1, run 1. So for line B, the slope, for line M, the slope is 1. And for line P, the slope is also rise 1, run 1, is also 1. So these two lines have the same slope, but different y-intercepts, which means they never intersect. So this is our answer. Okay, now let's inspect the other lines just to ensure that our answer is correct. Take a look at option C. We have an intersection here. That is a solution. This has a solution, so that's no good. Option B, we have the two lines on top of each other. Even though they have the same slope, they have the same y-intercepts. What does that mean? It means that this has infinitely many solutions. Everywhere on every exact value is a solution, so it has infinitely many solutions. All right? And then take a look at option D. We can clearly see that they intersect right here. Okay, so this has one solution, this has one solution, this has one solution, and this has infinitely many solutions. Okay, that's infinitely or infinity. So the answer is option A because these two lines never intersect, which means they have no solutions. All right, let's take a look at question number 10. It says Bart is training for a race in which he will run, swim, and bike. The Venn diagram below shows the number of days in July that Bart trained for each part of the race. So based on the Venn diagram, which statement is true? All right, let's take a look at the A, option A. It says that every day in July that Bart trained for running, he also trained for biking. So what does that mean? It means that all the days that are in running must also be in biking. Okay? So if you look at this Venn diagram, are there any numbers that are in running and not in biking? The answer is yes. We have 2 days that are running alone and 2 days that are running and swimming. So we have 4 days that Bart ran and did not bike. So this option is false. Okay. Now let's take a look at option 2. It says Bart trained for running or swimming every day in July. So if Bart's trained for running or swimming every day in July, that means that he devoted absolutely no days to biking. All right. So if you look at this Venn diagram right here, are there any days that Bart biked? The answer is yes. Bart biked for 9 days and ran those 9 days too. And then Bart also biked for 5 days, and he also ran and swam on those 5 days too. So for a total of 14 days, Bart biked and did something else. So is this statement true that running and or swimming are the only 2 things that Bart did in July? It's false because he also biked for 14 days to be specific. Now let's look at option C. It says Bart trained for swimming on more days in July than he trained for running. Okay, so all we just simply do is find the number of days that Bart swam and the number of days that Bart ran, and see if we have more swimming days than running days. Okay, so how many days did Bart swim? So swim days. We have 11 plus 2 plus 5. That's 7 plus 11. That's 18. This must exceed the number of running days in order for this statement to be true. Okay, so running days, they are how many? 2 um, plus 5, 7. 7 plus 2, 9. 9 plus 9, 18. 18 in all. So did Bart swim for more days than run? The answer is no. He did exactly the same number of days. He spent exactly the same number of days for both activities. So this statement is false. So by elimination, you can see that our answer is option letter D. Okay, now let's go ahead and let's go over option D to make sure that our answer is in fact correct. So for option D, it states that every day in July that Bart trained for biking, he also trained for running. So that means that for every day that um, Bart biked, he must also have ran in those days. Okay, so there isn't any day that Bart biked alone. So if you look at this Venn diagram right here, how many days did Bart spend biking alone? 0 days. Okay? How many days did Bart spend biking and swimming only without running? 0 days. All the days that Bart biked, he also ran. How many days were there? 9 plus 5, 14. So the 14 days that Bart biked, he also ran. So that automatically tells us that option D is the correct answer. Okay? Every day that Bart biked, he also ran for namely 14 days. So this is the correct answer. So thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to the remainder of this review series. If you have any questions, comments, or clarifications that you have for any of these problems we went over, we'll appreciate it if you include it in the comment section below this video. And also visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra to calculus. Thanks again for watching and have a wonderful day.